Hi everyone, my name is Anvita Bansal and today we are going to discuss minimum platforms problem from your SD sheet. So you all can see it here from the SD sheet. If you go and here you click on solve minimum platforms. So you come up with this problem. So let's go through the question. I assume you have already gone through it, but let's start with it. So you're given an arrival and departure times of all trains that reach a railway station. Okay, these are the arrival times and these are the departure times. Find the minimum number of platforms required for the railway station so that no train is kept waiting. Okay, consider all the trains arrive on the same day and leave on the same day. Arrival and departure time can never be the same for a train, but we can have arrival time of one train equal to departure time of the other train. At such an instance, also you need to consider same platform cannot be used for both departure of a train and arrival of a train if the arrival of one train is colliding with the departure of other train. In that case, you consider another platform that you will be needing. Okay. So you need to find minimum number of platforms required so that arrival and departure of trains can happen. Okay, so I hope you have already joined it and you all can see my screen as well. Let me check. Okay, so moving to the whiteboard as we usually do and try to understand this problem. I have already taken this test case from your given question. Let's try to understand it in this way. So there are obviously more than two approaches. But the brute force approach would be like, first for that you need to understand the question. What does the question say? So let's say at 9:00, that is at 9 a.m. Okay, a train arrives. One of your train arrives at this instant, which is something like this. Okay, let's see. So arrivals I am writing with blue. So here comes your train 1 at what time? 9:00. Okay, then what is the corresponding index in your departure array tells at what time the train leaves. So this train leaves somewhere at 9:10, right? This is your 9:10. Then there is another train which arrives at 9:40. This is 9:40. So 9:40 is after 9:10 only. Okay, so we can assume if this train took some platform P1. It has already gone from there by the time another train has arrived. So P1 is still empty. It was first used by one train and then it is now left empty once it leaves because the other train arrives after the departure of the previous train. So I can say it can still use P1. Okay. And what time does it leave? The train that comes at 9:40 leaves at 12 p.m. Okay, fine. What time does the next train arrive? That is at 9:50. So this next train arrives at 9:50. Now do you see one thing? Let me do it in some other way for better understanding. 1 second. I'll be using the same colored pen for the same train that is arriving and leaving the platform. Just for your understanding, nothing more about this diagrammatic representation. Okay, so this train comes and departs at 9:10. The other train comes at 9:40. The other train comes at 9:40. So let it be somewhere here. This is 9:40 and leaves at 12. Let it be here. So this is 12. Okay. And by the time the next train which comes, it comes at 9:50. So let's say this is the time at which the next train comes. This is 9:50. What time does it leave? It leaves before this 12. That is 11:20. So I can put it somewhere here. 11:20 is its departure time. Now, do you see one thing? This train 1, T1 comes and goes. So the platform which it uses, it makes it available for the next train. The next train T2, which comes at 9:40, let's say it uses P1. Okay. And next train T3 comes at 9:50. When it comes at 9:50, P1 is still occupied, right? Because T2 will go at 12. And by the time T3 has come at 9:50 and it will leave at 11:20. So obviously some different platform I'll need to allocate to it, right? So coming to the next one, let's say the other train comes at what time? 11 o'clock. The other train comes at 11 o'clock, which is somewhere here, let's say. So this is your next train which comes at 11, right? And what time does it leave? It leaves at 11:30. So it will leave at 11:30. Okay. Now T2 is there at P1. Its arrival and departure is 9:40 and 12. T2, T3 comes at 9:50 and it will leave at 11:20. Now I have T4, which is coming after my T3. Obviously, this is at 11 o'clock, right? And when it comes, what is the departure of my previous train? So this T2, this T3, which is coming at 9:50, it is leaving at 11:20, and I am coming at, and this another train is coming at 11. So obviously the departure of my previous train is still not has still not happened. And if I talk about the other train that has come at 9:40, it is still occupying P1, right? P1 is occupying, it will leave at 12. I'm writing the departures here. P2, which has come at 9:50, it will leave at 11:20. So I will check that my previous trains, whichever are there, they have not yet left, and I have come at 11. So basically, I'll need some other platform which is P3, because I am coming at 11 and the other two platforms are already occupied. What time will I leave? I'll leave at 11:30. That's what T4 will say. Okay, fine. Next one. After we have this train coming at 3 p.m. So I can write it in this way. At 3 p.m. it comes. So this is your other train coming at 15 and leaving at what time? Somewhere at 7 p.m., right? Then you have this other train which comes at 6, right? It comes at what time? 18:00 and leaves at 20. So I know for sure by the time my this train comes, which comes at 3 p.m., what are the departures that I am yet to do? I am yet to be done with the departures of T2, T3, and T4. And by the time T5 comes, that is at 3 p.m., 15:00, all the departures must have already taken place. So I'll have all my platforms free. So I can again utilize P1 or any of P1, P2, P3. So till now, what was the maximum number of platforms that were occupied one at a time? That was 3. So min platforms that I would be required. Don't be confused with this max and min terminology that I'm using right now. So maximum platforms that were occupied at an instant at for some time, such that there was an overlapping of interval, that was 3. And after that, when another train T5 comes, it will take P1, one other platform, and it will leave at this 8 o'clock in the night, and then T6 comes at 7. I will check the departure, what I'm yet to be done with. So this departure is yet to be done at 20:00, and I have already come at what time? That is 19:00. That means I cannot take P1, but I can take another platform, let's say P2. So at this interval of time, maximum platforms that I'm utilizing is 2, right? So till now, what was the maximum number of platforms that I'm utilizing for that some duration, such that my intervals were overlapping? It is 3. So the answer that I'll be returning should be 3. So that is, according to problem, that is the min platforms you are using to manage the overlapping times of the trains, right? How do you do that? How will we check it. So you have seen this thing that arrival times, whatever the arrival time of some train, let's say ith index, whatever the arrival time of train is at ith index, I am making some comparison with the departure time of the previous train, let's say. I'm not saying I minus one, but yes, my comparisons are being made for that index with the departure time of the other train, XYZ train, whatever it is. So, can I understand it in this way? Have a look here. That let's say your trains were arriving, and at this instant of time I am saying that I am sorted my arrival time of interval. So on sorting arrival I am going to get the same, on sorting arrival I'm going to get the same array here in this test case, but I am asking you to sort ARR and depth. Okay, sort ARR, arrival time of trains, and sort departure times of these trains. Why? So you will understand. So arrival is going to give me 9, 9:40, 9:50, 11, 11, 15, and 18, right? Departure time is going to give me, first it is 9, 10. Okay, then I will get 11:20. Then I will get what? 11:30. And this convention is according to me, but these are simple integers, so you can obviously easily sort them. Okay, so 11:30, after that I'll get 12, then 19, and then 20, right? That's what you're going to get after sorting both the arrays. Now try to understand it in this way. See, so some train comes at 9, right? This is at 9, and some train leaves at 9:10. Okay, some train comes at 9:40. Fine. Let's say you are using some I index to iterate over your this, and some J index to iterate over this. We will be using I for, let's say, iteration over arrival array, and J for iteration over departure array. So when you are at 0th index, you check what is your arrival. Your arrival is at 9. What is your departure for that Jth index? That is 9:10. You compare both of them. Is 9 smaller than 9:10? Yes, it is. If, what I'm saying is, in that case, if your arrival of I is less than or even equal to departure of J, then you are using one platform for sure. You are using one platform for sure. Till now, there was no platform used. Now you are saying that, okay, here I'm writing the usage of platform. So here I'm writing the usage of platform at this index in when I was 0, then platform was 0. One second. Let me write it here. So let's have a look here. When I was 0, this is the number of platforms. Platform is going to be 1, and also simultaneous J's. This is I, this is J. J is also 0, I is also 0. Platform is going to be 1. Why? See, when ARR of I was less than departure of, you don't have to bother about, you don't have to care about whose departure it is. We just want to know when is arrival, when is departure, whichever train it is. For sure. Okay, so I know any train is arriving at 9 and some train is leaving at 9:10. So in that case, one platform must have been used. So for that, I have already incremented the value of platform. Now my I is incremented. Now my I is incremented, goes to next index, which is at this index. And also, when you're at this index, okay, then you also simultaneously increase your I plus plus. Fine. Now you are at this position and your J is still at this position. So you are going to check. Otherwise, in other case, this was a case when ARR I was less than departure of J. Else, if your arrival time ARR of I is greater than your departure of J, then what is going to happen? If that is the case, that means then one train which is leaving at 9:10 must have already left. So one platform that at least this train was using must have got free by that time. So there will be no increment in platform. So you must go and check for the other index in your departure area. The comparison should be made for other index. So for that case, you will just increment the count of your J. Fine. That is what you're going to do in the second case. Now you are at this position. You are at this position. Again, your I is at this position. So what do you want to do? Before that, there are also few things that we will keep filling. The pseudocode I'm also gradually writing, but we will fill up by the end of this dry run. And then you do this J plus plus. Fine. Now you are at this position. Your I check ARR of I is less than, yes, it is. So your platform should be, now your I is at what position? Your I is at this position. I'm writing it here. I is at 1. J is at which position? J is also at 1 and the platform should be 2. Why? Because platform you are increasing if this condition holds true. That means it is coming at 9:40 and leaving at 11:20. Right? 11:20. Okay, so the number of platform should be 2 because some platform it is already using. Also one thing, actually not 2 here, it will be back to 1 only. Why? Because see, when this train came and this left, it came at 9 and some train left at 10. So the platform it was using when this train arrived at 9:40 and there is some train that is leaving at 11:20. For that we are doing plat plus plus. But if this case holds true, that was for when we were at 9:40 and we were comparing for 9:10. In that case, what will happen that the train at 9:10 has left the platform. So you will also do plat minus minus. Okay. And you are also separately using some answer that you want to return. In answer, you are storing the max at any instant. Till now, the max is one. Max answer is 1 that you want to return, and platform was 1. With this condition, your platform became 0. And when your I was at 0 and J, when your I was at 1 and J was at 0, so that in that case, platform became 0, and now it has become 1 again. Now, what are the indices? Okay, fine, and then you are at this position now. Okay, look at the next iteration. So I is at this position. Check for the condition. ARR of I, it is less than departure of J. Yes, it is. Okay, then what? Increase your platform. So increase your platform, and it was 1, so it will become 2. Now where is J? J is at 1. I is at 2. Fine. Okay, then again I plus plus. Oh, also we are done with this. Then you also check with, once you are done with I plus plus, your I is at this index. If you have checked, you made the iteration, then also you must have gone to else if condition when you were here. ARR of I is greater than dep J. No, that doesn't hold true. So again, we increment the count of I was already incremented. You again check 11 with J. So at 11, it is less than departure of J. So your platform would have increased. Answer would have been 2 at that time. So now the iteration is at I is at 3, J is still at 1. Your platform has become 3, and your answer will is the max of platform, is the maximum platform that you are consuming at any interval is will be stored in answer. So this is the current situation. Now since platform has increased, you are hereby checking answer is equal to math dot max of answer which you want to return and the platform at that point in time. Okay, so that is what you're storing in answer, and then you are doing I plus plus. Okay, then you were at which position? Your I was at 3. Your I has come to this point now. Again, you check. Okay, before it has come to that point, you check 11 with 1120. ARR of I is greater than departure of J. No, it is not. So it doesn't help us. Okay, we are at this position. We are at this position. Now we check the train coming at 3 with 1120, which condition it goes to. ARR of I is greater than departure of J. So obviously your J has increased by 1. It is incremented because there is some train that is left at 1120 and I am coming way after that train. So the platform will be releasing now. So the platform will become from 3, it will become 2. And at what instant it is becoming 2? When my J was at 1 and my I was at 4. So at this position, platform became 2. Now my I is still at 4. I am again checking which condition holds true. ARR of I is being compared with departure of J. It is again greater. So when greater case, I go to else if. So I is still at 4 and your J has come at next position 0, 1, 2, which is 2 towards index, and your platform has reduced again, which will become 1, and you increment the count of J. Again, you do the comparison I with J. I is again greater than J. It goes to else if condition, does nothing but increases the count of, decrements the count of platform, which will become 0. And your I was at 4 only, but your J was at 3, 0, 1, 2, 3, and that is how your platform has become 0. Answer is still stored with 3 because it has always stored the maximum of answer and platform. Platform is kept reducing because as as the other train which is coming at whichever train it is coming at 3 p.m., the other trains which had occupied the platforms are releasing the platforms now. So for that I am reducing the count of platform. Okay, now I'm at this index. So when I compare it again, your J will be incremented and it comes to this position. When it comes to this position, the comparison will be for this condition. ARR of I is less than your departure of J. Platform will be increased to 1, right? Answer is still stored with 3 and I is incremented at this position. So I, this was for your I was at which position? 0, 1, 2, 3, 4. And okay, 0, 1, 2, 3, 4. Fine. So for this case, I have already added the count of my platform. Now my I is at this index. Which case should it go? It should go to if condition because my ARR of I is less than my departure of J. So the platform will be increased to 1. So this is for the index where my I is at 5th index. My J is at 4th index and the platform is incremented to 2. Answer is still 3. And then you do I plus plus. Your I is out of bounds now. It has reached the maximum index of your array. It has gone out of bounds. So there are no more incoming trains. So whatever answer is stored with maximum, that is what you are going to return. So once you are out of the loop, so basically you're running this loop for while I is less than n and your I starts from 0, and also you have taken a J counter which starts from 0, and although you are handling the condition, you are handling the loop with condition that I goes till the last index of your arrival trains array. That would be the sufficient condition for this case. And once you are out of the loop, what you would want to return, you want to return the maximum platforms for any interval of time that were used due to the overlapping. So you'll return the answer which is storing the maximum, and that is 3 because I got 3 at this instant. Whichever instant gave me 3, that will keep on going in your answer unless you get an answer which is more than 3. If at any instant or if at any intervals you were using platform, let's say 4 number of platforms, your arrival and departures were in such a way that you were using more than 3, so answer would have stored with 4 at that index. for that index, and it would have continued with 4 until a value greater than 4 was found. So I hope this is clear. Any doubts so far? In SD sheet series in mathematics section of GFG, generating number is yet not part of our SD sheet, and since we are taking the questions which are already present in your SD sheet, but I can talk, and maybe we can have another section, not the next one, but maybe a dedicated section for this question, or even you can also DM me on LinkedIn. So if you want, I can have a look at the problem and take it separately. So, moving to the question now, I hope you have understood the explanation. This is what you need to do. So, what is the time complexity? We are sorting two arrays. One is arrival and one is departure. And like since we are using Java, we'll use the inbuilt function arrays.sort. And this uses n log n of time complexity. And since we are using it two times for two different arrays, it will become 2n log n, right? So precisely it is going to be n o of n log n, where n is the length of your arrival or departure array. Also you are iterating over the loop over these arrays twice, not as in nested ones. Like for ith one, at the worst case, what could be the case that you have iterated over the entire arrival array? That's what you are doing at least. And in the worst case scenario, you have also iterated over the entire departure array for the comparisons that we are doing. Okay, so in that case, it will be n plus n, that is 2n, right? So 2n log n plus 2n is your time complexity. So it will come down to the, we can ignore the smaller part, and it can be written as O n of log n time complexity. Space we have utilized, no extra space we are utilizing, right? Only the this merging space is being used, and that shall not be considered in the space complexity for this problem. So that is the time complexity, that is n log n. You're using this time. And the brute force that I was talking about, see now, since now you know, and this is the greedy approach that we have discussed. Greedy approach. In the brute force, what you would have done is, let's say you have taken this one interval that was given to you, and for this one interval, let's say this interval, now you have fixed this interval, because and then you are iterating over all the rest of the arrival times of the trains and the departure times of the trains, and you are checking that which interval is overlapping with your interval. Keep your interval fixed and then iterate over the arrival array and the departure array, and check simultaneously that which combination is overlapping with your combination. Similarly, do same thing for keeping this interval fixed, and the rest of the intervals that you are getting, you compare it with this. So maximum of time complexity in this case would be O(n) square, because whenever you are iterating, let's say I is equal to 0, you are starting, your j is also at 0, then you for I1 and j1, and keep on going and checking that which interval comes between the arrival and departure time of this. So the same thing you will do for this also, right? So that takes overall O(n) square of time. Okay. So the idea of this question was to introduce you with the greedy approach that we have used here. Not very intuitive when you first come up with this problem. You'll always obviously think of like this only. But yeah, once you are aware of the approach, I think it's very easy. That's the entire thing that you need to write. So let's move to the problem. Let's code it. So I'm taking plat I0, int J0, int platform 0, and int, let's say the answer that we want to return, it can be count also, count 0. Okay, so now let's run your loop while I is less than n. We are running a loop over one array's length, arrival array's length, and I starts from 0. So if your ARR of I is less than or equal to departure of j, that means platform is getting used. So platform plus plus, and also simultaneously store your maximum in count. Count will be math dot max of count, comma platforms, right? And then increment your I index and do the comparison with the j wherever it is. In the other condition, because you also want to, why else if and why not else? Because after, if we want to anyway, we want to come up at this condition and check wherever your j is present. Else if arrival of I is greater than departure of j, then what you are doing, you are simply reducing the platforms and incrementing the count of j's that go and check for the other comparison, right? That is what is happening here. And by the end of loop, you would want to return your count should have stored the answers. Check here. What is the answer? So this is what happened. Something is wrong here. Is greater than departure of j. Just a second. Let me check what is wrong with this. I0, J0. Plat starts with 0, counts, and you are returning what? You are returning count. Count and plat. Plat plus plus. I plus plus. J plus plus. What is the answer that you would want to return? Guys, can you figure out what is the problem that I might have made in this problem? Have a look. By the time I'm also trying to have a look at it. Biggest mistake is what I have done is, in my mind I was only working on the pseudocode, but I have ignored the fact that in order to run this loop, I also have to sort both arrays, right? So who will do that? I am running these two cases, only these conditions, once I'm sorting my array. Both the arrays precisely. Fine. So this is your problem. And that is all about this problem, guys. Yeah, I can have a look here. Just try it yourself. Try to dry run on some other test case. Maybe this is not a very good test case to understand the problem. So better to dry run by yourself also on this test case. And that's all about this problem. If you have any doubt, you can write it on the chat. Fine. Then see you all in the next lecture tomorrow. Thank you, everyone. Bye bye.